Hello, this is Mr. Wyrick. I'm here to talk to you today about lesson 10.6. 10.6 is over secant, tangent, and special measures. My writing's a little sloppy there, forgive me. A secant, this is our new vocabulary word for this time. It's a line through the circle that intersects at 2 points. So where we just had a tangent where it was touching at 1, we now have secant where it's going through, it's touching at 2 different points. So we immediately get into theorems about secants. Theorem 10.12, two secants or chords. Remember, the chords are the ones that have endpoints on the circle. The secant is just a line all the way through. If we have two secants or chords that intersect, then the measure of angle 1 here would be the average, essentially, of the two arcs that are on opposite sides here. So arc AB, this top arc for this top angle, and then the bottom arc for the same thing. We add those together, we divide by 2, that averages it out, and that gives us the measure of angle 1. For angle 2, the ones that would be on the left and right here, we take this small arc BC, we take this other arc AD, we add those together, we average them out, we divide by 2. And then that's going to be the measure of angle 2. Essentially, this is like we're cutting it in the middle, and we move that middle over to a different point. So it's not going to be that exact arc. It's not a central angle, but it's not an inscribed angle either. So we have to have a little bit of a different method. In this case, we add them together, we divide by 2, and that's going to give us the actual measure of that angle. Great thing about this is it doesn't matter which angle they're asking for, top or bottom on this one, to use those top and bottom arcs. And it doesn't matter which angle they're asking for, left or right on this one, as to how we're going to use those left and right arcs, because these are vertical angles. So if you remember back to the beginning of the year, when we first looked at vertical angles, any and all vertical angles formed by 2 lines crossing like that are going to be congruent. So 1 would be congruent to, we could call it 3 down here, 2 would be congruent to 4 over here. So it doesn't matter which angle they're asking for, you just have to pick the right pair of arcs for that pair of angles. Theorem 10.13. Theorem 10.13, if you want to write it down word for word for how it appears in the book, if a secant and a tangent, remember the tangent intersects at 1 point on the outside of that circle, and the secant goes through, intersects in 2 points, but it's not necessarily like a diameter. If they intersect at the point of tangency, which is the 1 point where that tangent line touches the circle, then it's the same as the inscribed angle. It's just going to be half of that arc. They try to make it something crazy, make sure, do this, divide by 2. Just remember on this one, if it's a secant and a tangent, that tangent makes it just like an inscribed angle. So the angle is going to be half of the arc. Now 10.14 is the one that's special. If we have 2 secants or 2 tangents or a secant and a tangent, if they intersect outside the circle, then again, I went with symbols rather than try to give you some kind of formula here. We have our point here, and we have an intercepted arc on the short side. We have an intercepted arc on the large side. We are going to subtract the larger, or subtract the smaller from the larger, and then divide it by 2. That'll give us that angle. So if this one's 100, this one's 40, that's 100 minus 40 is 60. Then we would divide that by 2, and that angle would be 30. This is one that you're really going to have to watch out for. It's a special case, and it's very different than most of the rest of these. For me, it's always been kind of harder to remember this. Same thing with the tangent, but you have to be careful because, again, my points of tangents in here would be B and C. So I'd say BC minus BC, but it's not the same BC, okay? The tangent points don't typically intersect where it would be a semicircle, so it's going to be a little bit different on that one. I don't think they ever can intersect on a semicircle to make it to where it's 180 degrees. This is a 90-degree angle that contains that circle. I guess it could happen, you'd have to be very careful in that situation. But make sure it's the BDC, the larger one. Subtract the smaller one so that you're not dealing with negative numbers, and then divide it by 2. That's going to give me that outside angle over there. Okay. Keep in mind on this one, I know that should be it. We talked about the circumscribed last time, so be on the lookout again for some circumscribed kind of polygons. They'll be looking for some angles on the outside of those this time, now that you know how to get that intersection on the outside there. But this is not just tangents, so they might focus more on secants with that. On page 745, there's a table. When it comes time to study for whatever test we have at the end of this chapter 10 thing, I would suggest copying down that table on page 745 and study from that. It's a quick guide method to study all of these different theorems, put them together, understand how the angle measures are supposed to go. And for the lesson today, you'll do numbers 8 through 35 and then number 40. If you have any questions over this stuff, something I explained wasn't clear, make sure you come in, you ask about it, and I'll do my best to help clear it up, or ask about it during class. We'll go through it as a class. If there's, I keep saying the same things over and over again, hoping to sound a little bit different, but I guess it's just going to be, we'll see you in class for this one, and I hope you, I don't know what to say.